Hey there. New week, new unit we're starting out. We're on to lesson 8.1, first lesson of this unit. So, our objective for today is to be able to describe how factoring is related to quadratic solutions. There's not going to be much class discussion, but you'll be answering questions along the way. And we're also going to be analyzing graphs on calculators. So if you have like the TI Inspire app, or if you just want to use Desmos or something like that, that will work. And that's just for looking at some pictures. There's not a lot of work being done on that itself. I'm just pulling up the Desmos app on my phone right now. Okay, so for the do now, it says think back to middle school. What are the factors of 12? Why did that pop up? So take a minute, see if you can list out all the factors of 12, and then we'll discuss it in a second. Okay, so factors of 12. The factors are the things that make up that number when you're multiplying. So when I like to do factors, I like to, let me see if I can get this looking okay. I'll do something like this. I like to start with, let's see, can I make this look nice? Almost. Okay, that looks okay. Made a little table just to not have to go over to the camera. So the factors of 12, I like to start with 1, and I think, what can 1 multiply by so that it equals 12? And I know that 1 times 12 will multiply to make 12. So those are my first two factors of 12, 1 and 12. And then I move on to 2, and I say, all right, 2 times what will get me to 12? And I know that 2 times 6 makes 12. And then finally, well, you don't necessarily know it's finally whenever you get to 3, but I do know because I know the factors of 12. I'll try 3, and 3 times 4 makes 12, so that's another set of factors. And this is how you know that you're done finding the factors if you're just going one at a time, is you go to the next number, and if the next number already exists in your list, so I have 4, but I already see that there's a 4 right over here, that means I know I've found all the factors. So the list of the factors for 12 are 1 and 12, 2 and 6, and 3 and 4. Wasn't there a question on the bottom of this thing? Maybe I'm going crazy. Yeah, so that's just like remembering how to find factors, and it's just the list of all the things that multiply up to make 12. So 1 and 12 is a pair of factors, 2 and 6 is a pair of factors, 3 and 4 is a pair of factors. Now, numbers are not the only thing that have factors. Expressions can have them too. And when we're talking about expressions, I mean stuff like this, like the quadratics we saw in that lesson from before. I'm just moving the chair down a little bit because I saw I was out of frame. So factoring is, let's get rid of that. Factoring is when you find the numbers, and I might even say or terms, or expressions that multiply to make a bigger number or term or expression. And you can think of factoring as the opposite of, it's the opposite of like multiplication. Multiplication or distribution, and we'll see what that means in the coming lessons when I say distribution. Though distribution, you should know, is kind of like a form of multiplication. Because what I'm doing is I have 12 and I'm breaking it out into two things that multiply up to it. So it's the opposite of multiplying. I know that 1 times 12 is 12, 2 times 6 is 12. So to get the factors of 12, or to factor 12, I say, all right, here I have 12. What numbers would I have to, like, what numbers can I pull apart that would end up multiplying to 12? If that's confusing, don't worry. But yeah, that's kind of what it is. It's just when you find numbers that multiply to make a bigger number. Jeez. And factoring is the opposite of distribution or multiplication. So, for example, let's take a look at this over here. I have 2y plus 3, and the y plus 3 is in parentheses over here. When I expand or a lot of times we'll call this distribution, I will do 2 times y, 2 times 3, and I end up 2y plus 6. To factor is doing the opposite of that. What two things can I multiply that make up 2y plus 6? And so I factor out, I split away the 2 from the y plus 3. It looks a little bit different, but if you think about it, from our do now, I had 12. I can split it apart into a 1 and a 12, or I can split it apart into a 2 and a 6. Here I have a 2y plus 6. I split it apart into a 2 and a y plus 3. And now this is where these pre-videos from last week came in. When I see something like this, this is the factored form of this quadratic. I have a standard form quadratic over here, and I know that it's a quadratic because it has an x squared right over there. And the factored form is I break it up and kind of change it to make two binomials that when I FOIL multiply these, or when I just box method multiply, or however you want to call it, they become this unfactored thing. So we call this factored version. The two different parts of it, the two binomials, are the two factors of this polynomial, this quadratic polynomial. And again, we saw this result from the last video. It says, notice how we get a quadratic from multiplying two linear factors. How do the roots of the polynomial relate to its factors? We're going to talk about what the roots mean, I guess, on the next page. So I won't go too far. But just saying, right, if we did the FOIL method, and we did this question in the previous video, so check that one for that, it multiplies first times first, outside times outside, inside times inside, last times last. It multiplies to make this quadratic. So it's just like when I say 2 times 6 makes 12, this factor times that factor makes this full quadratic. And that would be the multiplying or the distribution. And then factoring would be going from this form back to the other. We're just getting some idea of what factoring looks like. We're not actually seeing how to factor today, but we're looking at like what factoring is even for. Okay, so let's, it says, how do we get the roots of a polynomial? So this is where I want to talk about, and I want to use a Desmos, but let me read this first before I switch over to the camera. So it says, find the x-intercepts, which then means the root solutions are zeros, and we saw this from a vocabulary lesson from last week, to the following polynomial using the calculator. So I've got x squared plus 4x plus 3 equals 0. And let me pull up Desmos. All right, we're there. And nope, not that. Here we go. So we have Desmos pulled up on our phones, or, TI, whatever, whatever you're using. And even on just like the Chromebook that you're using or any laptop, you can also, I think, just go to desmos.com and it'll look similar to this. So if I type in x squared, plus 4x plus 3, what the heck? Plus 3 equals 0. It's going to give me a picture that looks like this. And if you look at this, the x-intercepts, the zeros, the solutions, the roots, whatever you want to call them, they all are the same thing, are the two places where this hits the x-axis. So it looks like it's hitting at, ooh, I can zoom in on this. That's so cool. I didn't know that. Oh, it's inverted? That's so weird. Okay, sorry. Phone, don't die on me. Okay. It looks like I am hitting the x-axis at -1 in the x and -1, 2, 3. So pay attention to those numbers, right? I'm hitting the x-axis at -1 and -3. If you look back over here, the factors were x plus 3 and x plus 1. And it looked like when I used the calculator, I hit the x-axis at -1 and -3. So, and as we saw on the page above, I'm not going to scroll up again, the factored form of this quadratic of x squared plus 4x plus 3 is x plus 1 and x plus 3 equals 0. And now the question is, how do the x-intercepts were right over here, hit the x-axis at -1 and -3. And I'll bring up the picture on my phone again. I hit here at -1 and -3. how do these x-intercepts compare with the numbers inside of the parentheses over here? So take a moment, try to answer that. And all right, I'll say it now, right? The video already paused for you. So they were the same numbers, but opposite sign, right? My x-intercepts were at -1 and -3. My factors were x plus 1 and x plus 3. So the numbers were the same, 1 and 3. It was just the opposite sign. And that's how, that's why this algebraic form of factoring is going to be important when we learn it in the future. Instead of having to graph it on a calculator, which is usually easier, you can do it algebraically and find it from the factors. So we know from looking at this that when I have a factored form of something, the zeros or the solutions or the x-intercept are the opposite sign numbers of what I see in the parentheses. And again, we missed the previous unit, so I'll say it one more time. When you are looking at a quadratic like this, a really important part is sometimes the vertex, which seems to be off, but also a really important part is what we call the solutions or zeros, and that is where your quadratic hits the x-axis. Those are the solutions to it. Just remembering that. Dang. Okay. So, given the following quadratics in factored form, what are the zeros? This becomes so easy because all you have to do is, if this is my factored form, the zeros are x equals 1 and x equals, 2. Because my factored form is x minus 1, x minus 2. So I know that the zeros or the solutions are just the signs flipped. And I want to take a moment to look at why that works. You don't need to do, you don't need to do this every single time, but this is why the solutions work and why we even call it the solution. So I'm going to copy down x minus 1 and x minus 2 equals 0. I might be getting a little ahead of myself here, but it's okay. So if I said, try to solve this to find what my x's could be, you might start by doing the FOIL, but then you'll find out that you end up with a x squared plus x or minus x plus 2 at the end. That's not good because I don't know how to solve with an x squared. But when I have a situation like this, especially knowing, hey, this just needs to be equal to 0, I can say, well, these two terms are multiplying. If I make one term, anything times 0 is 0. So if I make one of these terms 0, then I found the solution, right? And so I could say, well, what if I set x equals 1? What if I do that? If I set x equals to 1, I'm going to have to plug in here 1 minus 1, and then 1 minus 2 equals 0, right? I'm just substituting in x equals 1. 1 minus 1 becomes 0. 1 minus 2 becomes -1. And because this term is 0, 0 times anything makes 0, I made it work out. And this is where this whole rule of the solutions come from, right? If I have two binomial terms, an x minus 1 and an x minus 2, I know that the solutions are going to be the opposite of the signs that I see in there, because if I set x equal to a positive 1, it will make this first binomial 0, right? It'll zero it out. And if I set x equal to a positive 2, which is the opposite of this, it will zero that out over there. And whenever I make a single one of these guys 0, like I see here, 0 times -1 equals 0, that makes it work. Anytime either of these are 0, the whole thing works out because they're being set equal to 0 over here. So that is why it works. Hopefully you can go back and rewatch it to see why that makes sense. But basically, the reason that I have the signs being the opposite is because if I plug in x equals 1 over here, this binomial term becomes 0. This whole thing then, 0 times anything, will make 0 always. So the zeros, or the solutions, are always just the opposite of the signs in there, because if I set x equal to that opposite sign, it's going to make the whole thing equal 0. So, long roundabout, let's get to the answers here. The zeros are the solutions of the roots. When you see a factored quadratic like this, are just, I know, going to be the roots are x equals 5 and x equals -7, because it's the opposite of the numbers in the parentheses. And again, if I set x equal to 5, it'll zero out this term, which makes the whole equation work. If I set x equal to -7, sure, this part won't be 0, but -7 plus 7 will make 0. It will zero out the entire equation, and it works out. Let's look at this third example over here. X plus 8, x plus 11, and I want to find what are the zeros. And let me see, I already use zeros, roots, solutions. I'll say the x intercepts are x equals -8 and x equals -11. And then again over here, it's saying, well, what do you notice about all these examples? What are they all equal to? And they're all being set equal to 0. And let's yeah, all right, I won't get to it, but yeah, what are they all equal to? The equations are all, oh my goodness, equal to 0. Okay, so let's go backwards a little bit just so we can get the full context of it. We have a quadratic over here. It's asking, what are the roots? Do I want to talk about the other thing up there? No, I think it'll come together. What are the roots of this quadratic? And so I can see it is hitting the x-axis when x is 4, and it's hitting again when it is 0. So the roots of this quadratic are going to be x equals 0 and x equals 4. Now, and this is another reason why this, knowledge of factoring is important, is it says, all right, so here are my roots from the picture that's up over here, and it's asking what factors did they come from? And we can use what we learned from before to go backwards in the opposite direction, where I know if these are my factors, x plus 8, x plus 11, I know that the roots are x equals -8 and x equals -11. Well, if I know the roots, I can go backwards to get the equation to get the factored stuff, right? So if I know that my roots are 0 and 4, well, we know that the sign in the factored form is the opposite of the sign of the roots. So I could say, well, I know that this has to be x, let's put this in parentheses, get rid of that capitalization, -0, and then the other factor is going to be x minus 4, and I know that because the signs are the opposite, right? It was 0, I mean, really, x minus 0, anything minus 0, you could really just write this, if you want to be fancy, as x minus 4, because anything minus 0 doesn't change it, so I could just write that as x. But we'll leave it as this for now. This one comes from, well, it was 0, and I presumably, well, I'm not even going to say it. So I'll just put an x minus 0 here. This is a positive 4, so I'll put a x minus 4 over there. And again, these are all equal to 0. And the reason, by the way, why these are always equal to 0 is because when I'm hitting the x-axis, my y value is 0, right? That's where this equals to 0 comes from. When the y value is 0, these are my x's, right? This is the point 4, 0. This is the point 0, 0. The y in both of those is 0. That's why I keep setting it equal to 0 over there. Okay. Now it's asking, all right, multiply your factors to get this in quadratic form. So we're going to have to do our binomial multiplication of x minus 0 and x minus 4 to figure out the quadratic standard form. So let's do that real quick. I'll move the mouse. All right. So following, I'm just going to do the way I like it. So I'm going to do x times x times -4, distributing this first term to everywhere in the second binomial, and then -0 times x, -0 times -4. Let's see how it goes. X times x is going to make x squared. X times -4 is going to become minus 4x. 0, -0 seems kind of weird, but 0 times anything is just 0, so that's done. 0 times x is 0. 0 times -4 is 0. It looks like this is our full standard quadratic form of that factored form. So I'm going to write out. It's going to be, let's do a insert equation. What am I doing? No, over here. Insert an equation, and then I can type x squared, there you go, minus 4x. All right, let's do, I think this is it for this lesson, right? Yeah, we're at the end of the lesson. Sorry this took so long, and I talked like a lot. So the solutions to a quadratic are x equals 2 and x equals -5. This is asking us to then find the factors, multiply them, and write the quadratic in standard form. So I know that if my solutions or my roots or my zeros, my x-intercepts are x equals 2 and x equals -5, I know that my factored form is going to be x minus 2, the opposite sign, and x plus 5, the opposite of this -5, equals 0. And now all I got to do is just multiply here to find that quadratic in standard form. X plus 5 equals 0. Let's do it. So I'm going to distribute the x to the entire second binomial, and I'm going to distribute the -2 to the entire second binomial. X times x is going to be x squared. X times 5 is going to be plus 5x. That's the second part of the rainbow. -2 times x is going to be minus 2x. -2 times 5 is going to be -10. And then finally, I just need to make sure that I'm combining my like terms. So I have x squared, 5x minus 2x is going to be plus 3x minus 10. So there's my full quadratic form of the quadratic whose solutions are x equals 2 and x equals -5. Let's do another quick little equation here just so you can see it nice instead of my handwriting. So I know the answer is x squared plus 3x minus 10. And just to finish this lesson all the way out, final little thing that we'll do here is just try it out in the calculator. So it said, all right, I have a quadratic. I know the solutions are x equals 2 and x equals -5. We switched it to factored form by flipping the signs, and then we did FOIL, or just multiplying binomials, to get the quadratic equation given those two roots. So let's just make sure that that works out. So in my calculator over here, all I'm going to do is just try out the quadratic that I got. So if I type in x squared plus 3x minus 10, let's take a quick look at this. I see that one of my x-intercepts is 2, and the other x-intercept is -5. And my solutions, originally it said here's a quadratic who has solutions of x equals 2 and x equals -5. So it looks like we did it right. That's it for this video. Sorry, I had so many different tangents and I went on for so long. But yeah, there we go. First lesson of Unit 8.